Ever get that feeling like you've just hit a wall?
Hmm.
Not, a real wall, although I did walk into a glass door once. That was embarrassing.
Ouch!
Yeah. But more like this invisible barrier, right? That little voice saying, can't do that. Or maybe a limit the universe itself seems to put up.
Absolutely, that feeling of limitation.
So the big question we're tackling today is anything truly impossible? Or are we just sort of bumping up against the edges of what we currently know?
That's exactly it. We're diving deep into John D. Barrow's Impossibility, the Limits of Science, and the Science of Limits.
Hefty title.
It is, but it's a fantastic guide for exploring this surprisingly complex idea. What does it even mean for something to be impossible? Barrow really gets into the boundaries of our understanding.
Okay, so we're using Barrow's insights as our foundation, looking at how science and philosophy, too, wrestle with this whole impossibility thing.
Right.
And our mission, if you will, for this deep dive, to maybe uncover some, mind-bending insights into what gets labeled impossible and how these limits actually shape how we see everything.
Precisely. How they define our world, our place in it.
So let's jump right in. You mentioned something about a paradox.
Yes, the paradox of impossibility. It's this fascinating tension, really. Science, it famously progresses by proving the impossible is possible.
Yeah, like flying or talking instantly across the globe. Stuff people would have said was pure fantasy once.
Exactly. Science is always pushing those boundaries. But then you have philosophy.
The other side of the coin.
Kind of. Philosophy often steps in and demonstrates that things we think are feasible might actually be impossible, logically or conceptually. It asks the harder questions about our assumptions.
Okay, so science breaks barriers. Philosophy sometimes puts them back up or shows us they were always there.
But here's the twist, the real paradox. Science itself actually relies on certain things being impossible.
Wait, relies on impossibility?
Okay.
That sounds
Think about fundamental laws like the conservation of energy. You can't just create energy from nothing,
right.
right?
Right. That's a basic rule.
It's a fundamental impossibility.
Sure.
And science needs those fixed points, those you absolutely cannot do this rules. They provide the structure, the consistency. Without them, the whole scientific framework sort of unravels.
Yes. Okay, I see. Without those no-go zones, you can't build reliable theories.
Precisely. So it raises that question. How do we even figure out what is impossible versus what's just really, really hard?
Well, it feels like we humans, we have this urge to simplify everything, doesn't it? To boil reality down to simple rules so we feel like we've got a grip on it.
That's a great way to put it. We seek control through understanding, even if it's a simplified understanding.
I know I do that. Like trying to mentally categorize birds I see or something. Makes me feel momentarily organized.
And that drive is powerful in science. It leads to elegance, to unifying theories, but
There's always a but. What's the danger?
oversimplification. When we strip away too much complexity, we risk making huge mistakes, missing crucial factors because they didn't fit our neat little model.
Right, like trying to understand an ecosystem by only looking at one species.
Exactly. You miss the whole picture. It's this constant tension between useful simplicity and dangerous oversimplification.
Okay. Now, the sources also mention impossibility in games. That sounds a bit lighter.
It is, and it's a neat illustration. Take the L game. Simple setup. 4x4 board, 2 L-shaped pieces, 2 neutral squares.
Okay.
The goal is to move your L and maybe the neutral bits, so your opponent literally cannot make a legal move with their L.
So, impossibility within a closed system, defined by the rules.
Precisely. It's not about physics, it's about reaching a state where moves are logically impossible according to the game's own constraints.
And that reflects something broader about us.
I think so. This fascination with constraints, with rules, with problem solving within boundaries. We create impossible situations in games just to navigate them.
Like we enjoy the challenge of the box. Okay, interesting. Let's shift gears. Religious and mystical views. That seems like a totally different perspective.
It is. In many traditions, like the Judeo-Christian ones, God's defining feature is the ability to do what's impossible for humans.
Right. Miracles, things beyond natural law.
And remember that quote from Thomas Brown? To believe only possibilities is not faith, but mere philosophy.
Wow. That really draws a line, doesn't it? Faith requires stepping beyond the demonstrably possible.
It does. It highlights that gap. Our limits define the difference between the human and the divine in those frameworks.
And this connects to, like, shamans or magicians, too?
Yes, historically, demonstrating impossible acts, things outside normal cause and effect, was a way to confirm their status, their connection to powers beyond the ordinary.
See, the rules don't apply to me.
Essentially, yes. And related to this are religious restrictions, taboos.
How do they fit in? They aren't physical impossibilities, usually.
No, but they function as imposed limits, like societal rules or laws. They create boundaries on action, defining what is impermissible within that system, even if physically possible. It shows how deeply ingrained the concept of limitation, of impossibility in some form, is in human thought.
Okay, that makes sense. Now, logical paradoxes. This sounds like where my brain might start to hurt. Self-reference.
Ugh. Yes, they can be brain twisters. The sources call them unsettling because they mess with our tools for thinking. The classic is the liar paradox.
Oh, yeah, the Cretan saying, all Cretans are liars.
Exactly. If he's telling the truth, he must be lying, which means he's telling the truth. It's a loop. It folds in on itself.
Right, it breaks logic. So why the focus in the 20th century?
Because logicians realized these weren't just quirks. They arise from self-reference in language when a statement talks about itself or the system it's part of.
Okay.
The solution often involves distinguishing between the language itself and a meta-language, a language used to talk about the first language.
Like having instructions and then a separate manual explaining the instructions.
That's a good analogy. It creates levels and helps resolve the self-referential loop. It shows how deep these issues of language and logic go.
Wild. Okay, shifting back to science, you mentioned periods where scientists thought they were basically done.
Yes, like late 19th century physics.
Yeah.
Some prominent figures genuinely felt they were just tidying up the details, that the fundamental picture was complete.
And then, boom, relativity, quantum mechanics,
Yeah.
everything changed.
Completely. It shows this recurring tendency to underestimate the unknown. But contrast that with what the sources call our relentless desire for progress. Maybe it's evolutionary.
This drive to push, to know more, to fix mistakes.
Exactly. Progress isn't just new discoveries, it's correcting errors, refining understanding. It's a dynamic process.
The sources use analogies for how knowledge grows.
Yes. Several interesting ones, like islands of knowledge. Imagine different fields as separate islands. Progress involves expanding those islands, but the big leaps happen when we build bridges, when insights connect previously separate islands. It's called percolation, how understanding spreads and links things up.
I like that. Islands connecting into continents of knowledge. So what about ultimate limits? A theory of everything.
Ah, yes. It's important to clarify what physicists mean by that. It's not a theory that explains, why your toast burned this morning.
Okay, good.
It's about unifying the fundamental forces, gravity, electromagnetism, the nuclear forces, and understanding the basic particles. It's about the fundamental rules.
Not about predicting every single complex outcome from those rules.
Precisely. There's a huge gap between knowing the laws of physics and predicting, say, the weather next month, or the stock market, or consciousness. Complexity creates unpredictability, even if the base laws are known.
Like knowing chess rules doesn't mean you know how every game will end.
Perfect analogy. The world of outcomes is vastly more complex than the world of fundamental laws.
Makes sense. Now, philosophical insoluble problems. Du Bois-Reymond.
Right. He proposed two insolubilia problems he thought humans could never solve. First, the ultimate nature of matter and force.
Why insoluble?
His argument was pragmatic. We only experience the world through our senses, and we extrapolate. We can never truly access the infinitely small or the fundamental essence of things. We just build models based on observation.
So we're stuck with our limited viewpoint, essentially. What was the second one?
The origin and nature of consciousness and sensation, he saw this as doubly problematic.
How so?
One, how do you objectively explain subjective experience, what it's like of consciousness? And two, consciousness seems to introduce a fundamental unpredictability into the universe, maybe even defying purely physical explanation.
Whoa. So consciousness itself might be a fundamental barrier to complete understanding. That leads to the next point, right? Are our minds even up to the task?
Exactly. Our brains evolved for survival on the savannah, really suited for grasping quantum mechanics or the origin of the cosmos. Maybe our higher cognitive abilities are just side effects.
Like, our ability to do calculus is just a weird offshoot of being good at tracking animals or something.
It's a provocative thought. Maybe the universe is just, as Haldane supposedly said, stranger than we can imagine. Our evolutionary toolkit might be limiting.
Okay, that's a deep one. Let's talk practical impossibility. Things that aren't theoretically impossible, just effectively impossible.
Right. Computation time is a huge factor. The monkey puzzle example, 9 pieces, but 36 factorial arrangements to check.
Which is a ridiculously huge number.
Astronomically huge, far, far longer than the age of the universe for even the fastest supercomputer to check them all. So, solvable in principle, but utterly impossible in practice.
The Towers of Hanoi puzzle is similar.
Yes, the number of moves needed grows exponentially with the number of disks. These examples show that even with computers, there are hard limits based on time and complexity. Sheer scale creates impossibility.
Okay, so we have limits from complexity, computation, maybe our own minds. What about limits from physics itself?
Absolutely. Quantum mechanics gives us the Heisenberg uncertainty principle. You fundamentally cannot know both a particle's exact position and exact momentum simultaneously. There's a built-in fuzziness.
It's not just that our instruments aren't good enough.
No, it seems to be a fundamental property of nature. And then there's chaos theory.
The butterfly effect.
Essentially, tiny, tiny differences in starting conditions can lead to massively different outcomes later on. This kills the idea of perfect long-term prediction for complex systems, even if you know all the laws. Laplace's all-knowing demon is foiled by chaos.
So the universe has inherent uncertainty and unpredictability baked in. Wow.
It seems so. Interestingly, though, humans often create constraints in games, art, puzzles.
Right, we set up rules to play within. Why do we do that?
Maybe constraints fuel creativity. The sources mention Stent's idea that relaxing all constraints in art could lead to, well, nothingness. And Meyer's idea of stylistic stasis, where styles just coexist instead of progressing.
So maybe the limits, the impossibilities, are what give structure and drive creativity, like a river needing banks.
That's a compelling way to think about it. Which brings us to maybe the most famous impossibility result, Gödel.
Gödel's incompleteness theorems. Sounds intimidating.
They are profound. Basically, Gödel showed that any logical system strong enough to include basic arithmetic has a critical limitation.
Which is?
It must be either inconsistent, contain contradictions, or incomplete meaning. There are true statements within that system that cannot be proven true using the system's own rules.
Whoa. So even maths isn't perfectly self-contained and provable.
Not if it's complex enough for arithmetic. There will always be unprovable truths. Arithmetic truth outruns formal proof.
What does that mean for physics, for the universe?
Well, if the universe's underlying logic is like arithmetic, it might also be incomplete. There could be fundamental truths about reality we can never formally prove.
Right.
Or maybe the universe runs on a simpler, a complete logic. We just don't know. It's a deep question about the mathematical nature of reality.
It suggests limits to knowledge itself. What about the idea of truth, with a capital T?
Tarski's work in logic is relevant here. He showed you can't formally define truth within a sufficiently complex language itself. You need a meta language looking down on it.
So no single ultimate definition of absolute truth that captures everything.
Tarski's work suggests not. It implies layers of truth defined relative to specific systems or languages.
Okay, my head is spinning slightly. Let's touch on time travel paradoxes quickly.
Uh,
The grandfather paradox.
Right. If you go back and prevent your grandfather from meeting your grandmother, how could you exist to go back in the first place? It's a logical contradiction.
So if time travel were possible, it probably could involve changing the past in contradictory ways.
That seems to be the prevailing thought to avoid paradoxes. The past would have to be self-consistent somehow.
Got it. No timeline breaking shenanigans. What about prediction difficulties, the reaction game?
Ah, yes. This is about predicting systems where the prediction itself changes the outcome. Think economics or elections.
Like, if everyone believes a stock will crash based on a prediction, they sell, causing it to crash.
Exactly. The prediction becomes a self-fulfilling or self-defeating prophecy. Herbert Simon apparently thought he could crack election prediction by accounting for this effect, but the sources suggest he was mistaken. It's inherently tricky.
Very messy. Okay, nearly there. Impossibility and social choice. Voting paradoxes.
Yes, this relates to Arrow's impossibility theorem. It shows that under seemingly fair conditions, there's no perfect voting system that can always translate individual preferences into a consistent group decision without potential paradoxes.
Like A is preferred to B is preferred to C, but then C is preferred to A by majorities.
Exactly, that kind of cycling paradoxical outcome, it's more likely when individual preferences are very diverse. Sen's work looked at conditions where you can get stable outcomes, often when preferences have some shared structure.
So even collective decision-making has inherent logical impossibilities.
Yes, it really is. And people react to all these limits in different ways, don't they? Some find it frustrating, some see it as undermining science, others might embrace the skepticism.
But the point seems to be that exploring these limits, these impossibilities, hasn't stopped us. It's actually led to deeper understanding.
That's the key takeaway, I think. Impossibility isn't an endpoint. It's a signpost pointing towards deeper structures and questions.
So wrapping up this deep dive, it really feels like impossibility isn't just about what we can't do. It's fundamental to how we define what we can do, what we know, and maybe even who we are.
Well said. Pushing against these boundaries, even conceptual ones, is where so much insight comes from. It forces us to refine our understanding of possibility itself.
So a final thought for you listening. Given all these different kinds of impossibility, physical, logical, computational, philosophical, what does it really mean to know something? How should we balance that drive to understand everything with the reality of these inherent limits? Something to chew on, perhaps.
Indeed. The quest continues, even when we encounter the impossible, maybe especially then.